Hi, and welcome to day 2 of Calc Apps. Today we are just going to be talking about general rates of change. So what you need to know is dy dx gives us the rate of change in y with respect to x. For example 1, according to a psychologist, the ability of a person to understand spatial concepts is given by a equals 1/3 t squared, or square root of t, where t is the age in years, and t has to be between 5 and 18. A, find the rate of improvement in ability to understand spatial concepts when a person is 1, 9 years old, or 2, 16 years old. B, explain why dA dt greater than 0 is greater than 0 between 5 and 18 and comment on the significance of this result, and explain why the second derivative of A is less than 0 between 5 and 18 and comment on the significance of this result. So, for part A, we have A is equal to 1/3 t to the 1/2. And it asks us to find the rate of improvement. When every time it asks us to find a rate, that means we have to find our derivative. So dA dt. So 1/2 times 1/3 is 1/6. D to the negative 1/2. T to the negative 1/2. So that is equal to 1/6 square root of t. So that's my derivative. And it asks us to find when the person is 9 and 16. So 1, if t is equal to 9, then dA dt would be equal to 1/6 times the square root of 9, which is 3. 6 times 3 is 18, so it's 1/18. And what that means is, so therefore, the rate of improvement is 1/18th unit per year for a 9-year-old. Okay, and if t is equal to 16, dA dt is 1/6 times the square root of 16, which is 4, so it's 1/24. And that means the rate of improvement is 1/24th unit per year for a 16-year-old. I don't know what happened here, why it's supposed to be curve. Hang on. Okay. Part B asks us to explain why dA dt is greater than 0 between 5 and 18 and comment on the significance of this result. Well, as radical t is never negative, one over 6 times radical t cannot be negative. Therefore, dA dt is greater than 0 for all my values between 5 and 18. What this means is that the ability to understand, sorry, hit a button. So this means that the ability to understand spatial concepts increases with age. And for part C, my second derivative is less than 0 between 5 and 18 because the second derivative is equal to a negative 1 over 12 t to the negative 3 halves. So it's equal to a negative 1 over 12t to the 3 halves. So this means that while the ability to understand spatial concepts increases with time, the rate of increase slows down with age. So in other words, the older somebody gets, the easier it is for them to understand the spatial concepts. But as they get older, their ability to understand the concept will actually slow down. It's not that you won't understand it, you just won't understand it as quickly. The older you get, you'll still understand it. Your ability to understand it will actually be greater. It'll just take you longer to understand it. So it's kind of like the old saying, trying to teach an old dog new tricks. Well, you can do it, but it's going to take longer than it would a younger dog. The learning curve is greater. I guess you can also think of it as programming a DVR. You know, somebody who's older can definitely learn how to use a DVR, but yet it's going to take them longer to figure out how to program it. Yet a kid will go over there and program it with no problems. Show them once and they got it. Using a cell phone, a smartphone, for some older people is more difficult. They can learn how to do it, but it takes longer. Whereas a young kid takes one and they know how to use one and better than most people who are older. So that's kind of what it means. All right, let's look at this second example here. The cost of producing X items in a factory each day is given by our function C of X. And you see it's broken down to cost of labor, raw material costs, and our fixed or overhead costs such as heating, cooling, maintenance, and rent. So it costs them $2,200 just to open the door. Find C prime of X, which is called the marginal cost function. Find the marginal cost when 150 items are produced. Interpret this result. Find C of 151 minus C of 150 and compare this with the answer in B. So the first thing that it's asking us to do is find the derivative. Well, to find the derivative, C prime of X, I would just multiply 13 times 3 and keep my decimal point, so it's 0.00039x squared plus 2 times 0.002 is 0.004x plus 5. That's the easy part. Part B. Find the marginal cost when 150 items are produced. Well, so find C prime of 150 because C prime of X is our marginal cost function. So 0.0039 times 150 squared, oh, I'm missing a 0 here, plus 0.004 times 150 plus 5. When I put that into my calculator, I get $14.38. Interpret this result. Well, this is the rate, because I took a derivative, so it's a rate every time I take a derivative, at which the costs are increasing with respect to the production level X when 150 items are made per day. It gives an estimate of the cost for making the 151st item. So what this is saying is if we make the 150 items, to make the 151st item, it would cost us $14.38 to do that. Make that next item. And then for C, it asks us to find C of 151 minus C of 150. Now, notice that is back to the original problem. So C of 151 is going to be 0.00013 times 151 cubed plus 0.002 times 151 squared plus 5 times 151 plus 2,200. And when I put that into my calculator, I will get $3,448.19. C of 150 is going to be 0.00013 times 150 cubed plus 0.002 times 150 150 squared plus 5 times 150 plus 2,200. And when I put that into the calculator, I would get $3,433.75. I need to subtract those two. And when I do that, I'll get $14.44. And then it said compare this with the answer B. Well, this gives the actual cost. Of making the 151st item. Each week. So the answer in B gives us a good estimate. I mean, really, we are 1448 and 1444 and 1438, so we are 6 cents difference. That's pretty good when you're talking about just making your items here. All right, we are done.